Hello, everyone, and welcome to this webinar. We will be starting in a couple of minutes. So just I'll wait for a couple of minutes so that everyone is in the webinar and they're able to set up and they're able to hear us. So I'll start in a couple of minutes. Thank you.
I've been made to do this thing at 8:30 a.m. my time, so I must ask, where are you all joining from? What cities or countries are we all in here?
Feel free to drop in the country that you're joining in from.
UAE, all right. UAE, what is that, about 5 or 6 p.m. there? I don't even, okay. I couldn't even tell you what time zone UAE is in.
UAE probably is around 5 o'clock evening time.
Oh yeah, okay, no, I said, yeah, okay, I was good, okay. Yeah, UAE, India.
Okay, so I'll start sharing my screen and we will start the presentation and the talk. Give me a second, please. So my screen is here. Okay, it's time to begin. So thank you very much, everyone, for joining for this webinar today. Please note that this is a Zoom webinar and it is not possible to unmute yourself or turn your video on. If you have any questions for us or for Robert, you can drop it in the Q&A box, which is very easy for us to manage. So I would request you to please drop in your questions through this webinar in the Q&A box. Please also note that the webinar is being recorded and you can request a copy of the webinar by mailing to mathinfo@uwaterloo.ca, and we will be happy to send you a recording of this webinar. As we begin, we acknowledge that the Faculty of Mathematics at University of Waterloo acknowledges that it is situated on the Haldimand Tract, land granted in a legally binding treaty to Haudenosaunee in the Haldimand Treaty of 1784. Haldimand Tract and surrounding area, which includes 6 miles on each side of Grand River, is the traditional territory of Atawandran, Anishinaabe, and Haudenosaunee. So, hello everyone, and congratulations on your offer to be a Mathy at University of Waterloo. It is currently 8:30 a.m. as Robert said in Waterloo, and we welcome you from wherever you are joining us this morning or this evening. I just wanted to introduce myself first as I start the webinar. My name is Pavak Vyas, and I am the Undergraduate Recruitment Officer at Faculty of Math and at University of Waterloo. I will be the anchor for this webinar. I am joined by a few of my colleagues at Faculty of Math, University of Waterloo, who will also be answering some of the questions that you asked. So feel free to ask questions through this webinar. We are aware that past 1-2 years have been really challenging for all of us. Schools and universities have been moved to virtual learning and then in person and then back to virtual learning. Exams were canceled, delayed, and amidst all of these, you are here at the doorstep of a university, that too maybe in a different country. We understand you will have a lot of questions and anxiety about how your university life would be, how your academics at university would be, and therefore we have organized these samples, these series of lectures with some of our professors. So Robert Garbary is one of them, and he has very willingly joined this webinar. So just giving a little bit of introduction of the University of Waterloo, I'm sure you know, but good to know and much more clarity. So established in 1957, University of Waterloo is ranked one of the top universities in Canada on several aspects, such as research, publication, hands-on experiential learning, partnership with employers, and so many others. We have 6 strong faculties, 12 faculty-based schools, 4 affiliated institutions, and 100 plus buildings in a 1,000-acre campus. We are a city within a city. This makes us one of the largest universities in Canada with over 48,000 students, 4,000 alumni, 4,000 employees, and over 190,000 alumni across the world. University of Waterloo and education at University of Waterloo is a delight and a dream for thousands of students across the globe. Faculty of Mathematics at University of Waterloo is one of the largest faculty at University of Waterloo and is a powerhouse of discovery and innovation. As North America's only dedicated faculty of mathematics, we make world-leading contribution and create and attract industry leaders. With about $29 million of research funding, 260 full-time professors, around 8,600 undergraduate and graduate students, 45 different programs, over 500 courses, and over 40,000 alumni make us one of the largest faculty of mathematics in the world. And I'm very happy to be joined by Robert Garbary today, and it is my pleasure to introduce him. Robert earned his undergraduate in physics at St. Xavier's University in Nova Scotia and holds a master's and PhD in pure mathematics from University of Waterloo. He has been a faculty at University of Waterloo since 2015. And besides teaching first year and second year calculus, algebra, linear algebra proofs, he is also involved in high school outreach and the CEMC contest. Thank you very much, Robert, for joining us today. And yeah, the floor is all yours. I will stop sharing my screen and you can do that.
All right, sure. We, 1 second, let's see if I can find this.
Yes.
I do this, and then it should be, we had a few years ago, there was a day where we all had professional photographs taken by a really nice photographer, and I absolutely hate that picture they have. Anyway, it's all good. Yeah, so good morning, everyone. My name is Robert, and I'm just going to talk a little bit today about sort of what you should expect in your first term or first year if you come to Waterloo. Am I sharing the slides okay right now, by the way? Can people see this okay?
Yes,
okay.
It's all ready. Yeah.
All right, cool. Okay, let's see. Whoops, 1 sec. Okay, so about Pavic said most of that. I'll say a little bit, I'll elaborate on some of this a little more. So I've been living in Kitchener-Waterloo for about 14 years now. Yeah, so Waterloo is sort of a twin city with another city called Kitchener, and they share, they're sort of connected to each other. And I've been living here 14 years, and I love living in the city. I'm really happy to be here. I'm from a small town in Nova Scotia. That's a Canadian province on the East Coast, sort of that's by the Atlantic Ocean. Yeah, so I did my graduate work. So that's master's and PhD at University of Waterloo. That was from, I don't know, 2007 to 2014 or something like that. I might be getting it a bit wrong. Yeah, and then I've been a faculty member for about 7 years now, starting in around 2015. So that's my rough guess. Yeah, so I mostly teach first and second year courses here. So I mean, I teach first year calculus or the algebra course, which is really a proofs course, linear algebra. I've taught a few upper year courses in my time here. So I taught a third year number theory course last winter, and I've taught a third year group theory course when I was a grad student here. So sometimes do some mostly first and second year. I've also been in the last few years during COVID, I've done some online and some in-person stuff. I would say when the online stuff first, this big, I'm at home right now. I got this huge whiteboard installed. And when I was first doing online stuff, I would just sort of live stream myself in front of that whiteboard, but I've since gotten a little bit better at this sort of stuff. Yeah, so I also, Pavak briefly mentioned this, but I also help write the CEMC math contest. So I'm guessing that many of you here would have written the Euclid. Is that right?
You can respond to Robert.
Yeah.
Yeah.
Anyway, I see at least one yes here. So I'm one of the people who helps make up the problems that go on the Euclid. So I help submit questions that go on the Euclid, and I help test the problems of others. And yeah, so that's one of the really fun things I do with my time that I really enjoy. So I'm sort of heavily involved with the Euclid. Yeah, besides I do a lot of school visits. So I'll go to various schools and sort of talk to students about solving math problems. Yeah, so I'm trying to think. So besides a lot of Canadian visits in the last 5 years, certainly in the last maybe 6 years, I was in Vietnam, the Philippines, and India, each for a few weeks. And I've also given some online presentations in the last few years. I've presented to students in Africa, in Nepal, and I can't think of where else. So anyway, I do a fair amount of sort of problem solving presentations internationally. Anyway, so today I'm going to talk a little bit about sort of, preparing, I guess it's called preparing for university. So roughly speaking, these blur together a little bit, but there's two main things I'm going to talk about. So sort of mathematical preparation, and then sort of what I'll call lifestyle preparation, which essentially means lifestyle preparation is a fancy way to say you're going to have to work really hard and you should be ready to work really hard. But I'll say that in a slightly nicer way. Okay. So as far as mathematical preparation is concerned, so again, we get a huge variety of first year students here from different parts of Canada or different countries around the world. And we're totally aware there's always going to be some small differences in the mathematical background of everyone. Okay, that sort of, some people might be stronger with trigonometric functions, or some people might have not seen, cosines or as much or whatever. So one of the things we've started doing in the last few years is we have this first year math readiness course. It's called MTHEL 99. I forget what that stands for, but I call it the math readiness course. You will, if you choose to come here, you will automatically be enrolled in this. All right. This year it's done online. It's not in person, it's done online. Yeah, so it runs from August 2nd to September 6th. I looked up those dates about 20 minutes ago, so I think, yeah, I'm updated for this year. And it's designed to take about 3 or 5 hours each week over 5 weeks, okay? And you do it at your own speed, okay? So it's all, there are pre-recorded videos and there's problems you work on and submit answers to. There's no extra cost associated with this. You don't pay extra for this or anything. And it's not mandatory that you do it. So even though you're automatically enrolled in it, you're allowed to drop it if you want, but we really recommend that you do this. And it covers the basics of sort of roughly the topics, inequalities and absolute values, radicals and rational expressions, trigonometry, exponential, logarithmic functions, polynomials. The website also says introductory calculus. I don't actually know off the top of my head what they mean by that, but anyway. So basically, if you choose to come here, you're automatically enrolled in this course. There's no extra cost associated to it. You're not required that you do it, but I really, really recommend that you do it. Okay, and this sort of covers what we're expecting that coming into your first year here. As far as a resource goes, I guess this is set up in hyperlink, meaning you can click it, but I don't think you guys can click on it. But so at the CEMC, at the Center for Education, Math and Computing, where the Euclid is done, we've produced all this sort of online courseware that sort of, again, roughly covers these topics I mentioned above. And there's sort of videos and materials there. And if you're looking for some stuff to do to help prepare, I'd really recommend going through this courseware, okay? And in fact, a lot of the math readiness course materials taken directly from the CEMC courseware. Okay. Again, I don't know if you can click on this link, but if you just Google CEMC courseware, there's sort of all of these topics. There's a lot of videos about them and problems to work on and stuff. Yeah. So again, if you're looking for something to do to help get ready, this would be it. Okay. As far as classes are concerned, I'm just going to read the chat real quick. Oh, thank you. Someone actually linked. Okay. Yeah. Okay, as far as Okay, so as far as classes is concerned, something I always tell my students on day one is that it's not my job to make sure you learn the material. Okay. And I really want to contrast this to high school, where in some sense it is your teacher's job to sort of make sure you learn the material. Okay. It's your job to make sure you learn the material well enough to pass the course. Okay. And I'm not saying this to be a jerk. Okay. It's just that sort of, you know, it's you're in charge of sort of making sure that you know what's going on. Something I also tell my students is, you know, what are my jobs as instructors? So my jobs as an instructor are, one, to sort of present the material to you in the best way that I know how, and sort of to think of different ways to present the material that I think will be helpful. It's also my job to help you if you ask for it. But the if you ask for it is a big part of it there. And then it's also my job, I help make up the assessments that you write. So assignments or quizzes and exams and whatnot. And in high school, at least I think this is probably true for all of you, that sort of you have time in class to learn things. Okay, that sort of you'll see something new for, I don't know, 10 or 20 minutes, and then you spend the rest of class doing problems related to it or so on. This is not going to be the case in university courses. Okay, that sort of you're not going to have time in class to get comfortable with things. Okay, class is going to go fast. Okay, and it's your job to sort of take the time outside of class to try to really absorb the material. I always tell students that there are going to be days when you're going to leave class feeling confused. All right, that you're going to sort of, you know, I'm going to say something, one of your professors is going to say something you don't really understand, and you leave class, you know, wondering, you know, what were the last 20 minutes all about? And that's totally fine. That's a normal thing that I think all students do. And again, I tell students to expect this to happen to them, but I'd also say it's your job to not be confused before the next class starts, right? So again, you're going to leave class being confused sometimes because we're going fast. There's lots of sources available to help, but in some sense, it's your job to seek them out. So a lot of resources we have for first-year students, you know, I mean, I'm a good resource if you ask me questions. There's the tutoring center. So there's sort of a group of graduate students and first-year students who have taken the course before you're in, and they can answer questions about the material. Your peers, your fellow students are really good resources to talk about with them, or study groups. So there are a lot of resources available, but it's your job to seek out these resources. Yeah, so this is just, I say, you know, it's okay to be confused, but it's not okay to be confused a week later. Okay, it's your job to figure it out. Another thing I tell my first year students is you've got to be able to sit down and really focus on a problem for 15 to 30 minutes without any distractions. For what it's worth, I have all the time, I get students who are doing poorly saying, you know, I don't know why I failed the midterm. I studied for 6 hours a day, and I really don't believe them. Okay, and most of the time I talk to them, they say that they're playing with their cell phone the whole time. And again, like, being able to ignore your cell phone and just sit down and focus for, you know, 15 or 30 minutes in chunks like that is something you have to be able to do. Okay. And for nothing else, by the way, you have to write a final exam at the end of the term that's probably 2.5 hours long. And guess what? There's no cell phones there either. So it's really good practice for that. Yeah, can't tell. Hopefully I'm not forgetting to say something here. So you're going to be asked to try to solve problems where you aren't told ahead of time how to do it, right? And sort of coming up with the method to use is part of the challenge, right? So again, it's not just going to be like we do the example in class and then you have to do it with slightly different numbers. Okay, it's going to be, here's something you haven't seen before, and part of the challenge is you deciding how to approach it. You again, expect to struggle being not sure how to even start a problem. Okay, that's going to be a normal thing, and that's part of learning math at a university level, is to sort of struggle and not be sure how to do things. The struggle is good, right? In the same way that, you know, if you're learning to play a musical instrument, or if you're trying to play a sport at a high level, sort of most of the really good learning happens when you are struggling with things, right? But the goal is to struggle in a good way, right? To sort of struggle in a way that helps you make progress. So anyway, sort of expect to come in and say, here's a problem I have to solve, and I'm not really sure what to do. I'll also say it's really easy to sort of search a lot of these problems. You can search them on the internet for assignments. For what it's worth, I always recommend that you don't do this. Okay. The goal when we have assignments and quizzes over the term, the goal of the assignments and quizzes is not to get marks or to get the right answer. It's to learn the material so that you're ready to write the midterm and final exam. Okay. Again, I couldn't tell you the exact numbers, but it's pretty common in these first and second year courses for the midterm and final exam together to be worth 80 or 85% of your final grade. Okay. And so sort of you should view the assignments and quizzes are there to help you learn the material to get you ready to write the exams. It's pretty scary, by the way, being told you have a final exam worth 55% of your course grade or something. Sorry for scaring you, but for what it's worth, any university you go to is going to have this sort of thing. So this is not a university only thing. This is not a Waterloo only thing. The other thing is a lot of the questions are going to be, it's not just going to be, come up with this number that's the final answer, right? A lot of the questions you're going to be solving are going to be, show that something is true, okay? And your solution is going to be an explanation for something, and it's not really a final answer. And we're going to be grading you on how well you explain something, okay? This is part of, so you're going to take, most of you will take a course called Math 135. It's called algebra, but it's really, I think it should be called proofs, but that course is really about sort of how to write down mathematical proofs and how to write mathematics at a sort of an acceptable way. Okay, so that's a first year course where it's specifically essentially about learning how to write mathematics. Okay, but again, it's not going to be about finding a number. It's going to be about sort of how well can you explain things. Yeah, I can't think of anything else to say, but maybe I'm forgetting something here. Lifestyle preparation. Yeah, again, this is essentially just going to be ready to work hard. But anyway, let's see what I can say here. So many of you are probably living away from home for the first time, right? And you're going to have sort of a lot more freedom than you're likely used to. Okay. So some of the things you're going to be responsible for, which maybe you're not used to being responsible for these things. So you're going to be responsible for sort of deciding when you eat, getting enough sleep. I absolutely promise you, I know lots of students who sort of get here and they stay up till 3 a.m. each morning playing League of Legends, and they sleep in till 10 a.m. and they miss their first class or something, and they're not working enough because of this. So again, it's sort of, getting enough sleep is something that you're responsible for. Going to class. Something I tell students is that you should go to class. Okay, that this sounds sort of silly to say, but I don't take attendance. You don't get in trouble if you don't come. Okay, but you should go to class. If you're confused about stuff, that's a really good reason to go to class. And if you're not confused about stuff, that's also a good reason to go to class, because it'll help you not get confused. Okay, so sort of no one's going to make you go to class, and your job is, you need to be the one who makes you go to class. Okay, and no one else is going to do it for you. Doing all your coursework. Okay, you're going to have assignment. A lot of courses are going to have weekly assignments or a weekly quiz that you need to prepare for. You're probably going to be spending a fair amount of time each week just reviewing course notes, stuff from class that you didn't totally understand. You need to think about a bit more and review your notes. Managing your social life, right? You're going to be meeting new friends. There's going to be sort of new social groups you're in. Without blushing, maybe some of you will be dealing with romantic relationships for the first time. And again, that's something that's also going to just, take up time. And the way I would summarize this, sort of the number one thing I would say about this is learning to efficiently manage your time is the biggest change you're going to have to face in going from high school to first year university. Okay. It's always going to feel like you have many things that you should be working on, and maybe there's not enough time to do them all. And you're responsible for planning ahead with time management and deciding how to allocate your time. Okay. This is the number one thing I would tell to any high school student thinking of going to university. That sort of learning to manage your time is the number one thing that you need to be ready for. I'd also say, by the way, it's like, I now have a job out in the real world, whatever that is, but like, I still like time management skills are one of the most important things I learned at university. Okay, that sort of, right now when I'm in my job, it always feels to me like there's lots of things that I should be working on, and sort of learning how to juggle all these things while I was in university really was help prepare me for this. So anyway, there's going to be a lot of stuff going on, and you've got to sort of, manage your time well. So let's see. Oh, it says the end. Yeah, so I guess now that I have scared you all, are there any questions? Yeah, so I guess I will turn it over to Pavek now, who's going to lead questions and answers, I guess. So anyway, thank you for listening to me rant for a few minutes, and I'll turn it over to Pavek.
Yes, thank you so much. This was most important piece of advice that I have always been hearing from university profs is, learn your time management very well. That's the first thing everyone should know in the university when they're coming into university. It's going to be so many things happening around that it is really tough to manage your time, and of course with added freedom. So that is the biggest piece of advice, everyone, that comes from none other but a person who's going to be a professor in a very short time. Okay, I have some question, Robert, and this comes from Awab Qureshi, and they're asking are there any books or resources that you would want to recommend to students to get used to the art of proofs that is different from what they do in high school, that they should do in the summer break?
Sure. So, right. So, I mean, my answer to sort of look at the CEMC courseware, that thing I linked, there's not a whole lot of emphasis on proofreading there. If you press me for a resource off the top of my head, one thing really worth doing, I would say, are going through the old CEMC contests. That there's lots of practice with proofreading in there, and they do post solutions. You can sort of compare them to there. Other than that, I'm not sure off the top of my head, but for what it's worth, we are expecting that when you show up on day one to classes, in September, whatever, right, that you sort of, various trig identities, or the quadratic formula. Okay, we're expecting you're comfortable with these things. We're not expecting that you are comfortable writing proofs. Okay, this is why we have a first year course essentially entirely devoted to this, where we assume that you don't really have a background with this. Okay, so it's not important that you're already good at sort of writing proofs when you get here. Okay, but if you want a resource, I'd say at the top of my head, sort of old Euclid contests are a great thing to look at, and I can't think of another thing off the top of my head.
Yeah, thank you so much. Next question comes up is about online classes. So someone wants to know about would the classes be online or in person coming September, and if the classes will be recorded somehow and they can use them as a revision at the end, maybe later on.
So I should say, I'm not sure I have the most current information about this, and arguably one of the 4 people here who aren't me or maybe the right person to answer this, but I believe right now the plan is that everything's going to be in person for the fall. That could change, right? I mean, it depends what happens in the next, 3 months or whatever. But I think right now the plan is that it's back to in person. Again, I don't know, maybe one of the other people here can tell me I'm wrong or something, but anyway, I believe that's what the plan is. And yeah, I mean, there's always been some courses we offer online, and sort of, but I think most courses are the courses that most of you are going to take are going to be in person this coming fall. That again, if nothing major in the world changes in the next few months, that's what I believe.
Yes, hopefully there are no more restrictions in traveling, and there are no more waves of COVID coming in.
Which I'm very happy about, by the way. I really don't like this whole online thing, and I'm sure none of you do either. But yeah. Yeah,
and it's been like 2 years they've been doing online, offline. That switch is really now becoming stressful. Okay, there is one more question, and this comes from Prabmeet. They're asking about, are there any updates for Euclid and CSMC cutoffs to automatically enroll in Math 145 or Math 147?
I'm not totally sure, but my rough guess is, so are there any updates? I mean, not that I know of, but my rough guess is to sort of, when you say automatically enroll, you mean that they'll let you enroll if you want, I assume. I don't think anybody is forced to take those courses. My rough, I mean, I think normally it's about an 80 or 85 on the Euclid, or about, I don't know, a high 40 or a low 50 on the CSMC. That's my rough guess, but I actually don't know.
Okay. Yeah. Great to have. I mean, a lot of things will get decided now. A lot of students do ask this question as well, Robert, is about the technology that they should be using when they come to the university. You know, do you recommend any typical operating system that they should be using, like, you know, Mac or
No,
Windows,
there's nothing like that. You should probably have a basic handheld calculator that can, you know, approximate, you know, the square root of 3 to 8 decimal places or something like that. But no, besides maybe a basic handheld calculator, there's nothing that you need to have. There will be some software you're required to use, but we give that to you. It's not expected you have it ahead of time.
All right. So there is no preference of whether they should use a Mac or a Windows computer. Okay.
No. Yeah, can I say one thing? I think the question disappeared, but I thought I would. So somebody asked me, I think there was a question that was deleted that said something like, now that we're in person, are classes still going to be recorded? Or something like that. Are there going to be recordings of things? And most of the time, the answer is no. Okay, there are some people who do record their classes and post them, but most of the time the answer is no. And it's sort of, it's your job. And this is why it's sort of, you could come to class. If you can't come to class, ask your professor for the notes or ask a friend for the notes. Now, for what it's worth, especially in your first and second year courses, we are going to be closely following a textbook. Okay. And it will be posted saying, you know, each day, here's roughly the topics of the textbook we're covering. And sort of, you can go and read that if you miss class. Okay, now you should be reading that anyway. Okay, even if you do go to class, you should still be reading the textbook. But yeah, one thing I did do for my students, so I taught first year calculus this winter, and it was in person. One thing I did, just because there was still sort of a good amount of COVID cases going around Ontario, and students sometimes had to miss classes because they had to isolate, is I sort of recorded a separate video and I uploaded them for students that they could watch in their own time later, just so that you wouldn't feel bad about missing classes. But certainly not all instructors did that. And if case numbers are going way down in 3 months, which it looks like they are, then I don't think I'll be doing that again, for example. Okay. Yeah. So anyway, for in-person classes, do not expect there to be sort of videos made if you can't go.
So you have to be in class and be attentive. It's not like you be in class and you will get a video. So you can be not that attentive. Anyways, thank you so much. There is a supplementary question on the books and calculators. So someone is asking, Varuni is asking about, should we have a scientific calculator or a graphing calculator? And would you recommend?
You don't need a graphing one. Yeah, scientific is fine. Yeah.
Okay. And do you read it? I mean, I know you answered it in a way, but still someone is asking, is it recommended to study from books or online resources and some other publicly available material?
So, I mean, for all your courses, there's going to be books associated with them. Okay. So, and a lot of the first year courses in math, they're actually sort of our in-house textbook, right? They're sort of, I call them course notes instead of books. And you know, you buy them, and you know that they're good, they're well written, and that they're not ridiculously expensive or anything. And those are the number one thing I would recommend spending your time reading from. Okay, whereas like if you are reading from those and you put in the effort to properly read them, you will be fine. Yeah, so sort of the course notes / textbooks that are included in the math courses are more than enough to succeed in the course. Yeah.
Okay. Um, yeah. There is one very interesting question. I don't know if you or how would you want to take it up, but there is someone who's asking is that they wanted to know what is the difference between a double degree math and business administration and a single degree one. If you can
Yeah.
explain.
Okay.
Choosing a double degree, they're probably scared of
Yeah.
having a
No,
lot of.
I am not capable of answering that. I honestly have no clue. Maybe there's somebody in the chat who like maybe some of the other people here could tell you that, but I honestly am not able to answer that question. I don't know. I apologize.
No, okay, so I can answer from the recruiter's viewpoint to this question is, typically a double degree course will be, you will be studying mathematics at University of Waterloo and you will be studying BBA at Wilfrid Laurier. So you are doing two undergrad degrees at the same time, which is of course going to be a little longer in duration. And you will, when you graduate, you will also be graduating with two undergraduate degrees. So you will have a BBA from University of Wilfrid Laurier and a BMath from University of Waterloo. And most importantly, I mean, yeah, it's pretty challenging and rigorous because you're doing two things at the same time, and you will have to be, as Robert said, great time management skills will be required. Your classes will not overlap. The scheduling is made in a way that there are different classes in different buildings, but you are not missing a class, but of course you will be having exams and assignments and a lot of stuff happening at the same time. So yeah, working hard is the only way, and time management skills. For more, you can write us to mathinfo@uwaterloo.ca and we will be able to provide a very detailed answer to that. Okay, there is one very interesting question that Advait is asking, which is about undergraduate research. So is it possible to do undergraduate research with interested professors, even whether they're in co-op term or not? And can students collaborate with professors in their research?
Yeah, I actually know the answer to this question. I believe I do. Hopefully I don't tell you something totally wrong here. But yeah, so it is possible to work with various professors doing research stuff, and that counts as co-op. Okay, so you are able to spend your co-op terms working for a professor doing research, and I certainly know students who have done this before. So yes, it is possible. Again, and I think you have to be sort of among the top of your class in order to be able to do this sort of thing. But yes, absolutely. You are able to spend your co-op term working on research with an interested professor. Yeah.
Great. Yeah. So those who want to be budding researchers, want to do something in research, good. This is a great answer for you.
Shocked I actually knew the answer to a question that's not just a math question. But anyway.
Yes. Okay, there is one interesting question is Muhammad Sheikh is asking, is it possible to score 100% in mathematics in the first year? I have heard that math is very challenging and pretty difficult even to score 90%.
Okay, I mean, so yes, it's possible. So for example, I had two sections of first year calculus this winter, maybe about 250 students between them. And I don't know, I would guess about 10 of them got a 95% or higher. 5 to 10 of them got about that range. So that being said, asking if it's possible is a lot different than asking if it's hard. So let me say, this should have been part of my presentation. Hopefully I remember to say it next year. All of you guys coming in here, I don't know what it is, but you have something like a 95 average in high school or a 92 average or whatever grade system you use. Okay, our programs are designed to challenge students with a 94 average in high school, or whatever it is. Okay, something I tell my students on day one, for example, is that a 75 is a good grade. And not in high school, but in our courses, right? If you get a 75 on a midterm, that's a good grade. Maybe you'd like to be doing better and put in more work, but a 75 is a good grade. Okay. So just to be aware that most of you are going to have your marks go down when starting university. Okay, and it's because we are really trying to challenge students who are as strong as you were in high school. Okay, and it's pretty common to have these first year courses have a final course average of, a high 60 or a low 70. Okay, now we don't specifically aim for that, but that's sort of usually what happens. Okay, so just anyway, it is certainly possible to get a 90 or a 97, but it's meant to be hard. Okay, and expect your grades to go down a bit. Okay, but again, and employers know this too, right? It's not like if you're applying for co-op jobs and someone sees you got they know, for example, that a low 80 is above average, and that's a good grade. Right? The employers also know this. Yeah. Anyway, so yes, it's certainly possible to do really well in these courses, and I encourage you to try to. But again, it is meant to challenge those of you who are coming here, and those of you who are coming here all had a 94 average in high school or whatever the numbers are.
Yeah. And then there is a completely contradictory question to this that has come up in the Q&A box. I am loving this, guys. Keep your questions flowing in, and we love to have all these questions with us. So there is someone who's asking, so are there any extra classes for people who are not able to understand a specific concept well, or maybe some tutorials or some
yeah, so there's lots of good resources. Okay, so for example, I spend quite a few hours each term just sitting down with students and talking with them about the material in a one-on-one setting. They come and ask me for help when we talk about things. There's something called the Mathematics Tutorial Center for first and second year courses. So it's sort of a building in the math, and sometimes it's done online too, but there's a building where there are people there who have taken the course already or who are experts in the material, and you go there and you can ask them questions and they'll talk about it with you. That's outside of class. Your professor is going to have office hours where you can just sort of go and ask questions or show up and listen to other questions. You can ask about whatever you want. Your peers are a good source. So there's lots of sources to help you if you're confused with stuff. Okay, but it's your job to use these sources. Right? I'm not going to tell you that you should come see me for extra help or go to the tutorial center. Okay, but yes, there are a lot of resources.
Yes, so I mean, to everyone in the audience, please note that this is very important. Professors are available, so is your seniors, and there are lots of tutorials and help available. It is you who have to go and take it. So, first year of college and university can be really hard, and take advantage of all the resources that we have for you to at Waterloo. I have another question, and which looks more like a philosophical question. Is Aman is asking about, so what should be the approach to understand material, as in first focus on concept or focus more on problems?
Sure. Okay, so Aman. Okay, so in the first year courses, you're either going to have weekly assignments or weekly quizzes. So a weekly, we post an assignment, you have, a week to work on a bunch of problems and you pass it in, or if there's a quiz, we'll probably post a practice quiz where it's similar questions about the rough material. Okay. The first thing you should do out of class is, rather than reviewing your lecture notes, go try to work on the assignment or go try to work on the practice quiz. Okay. And when you get stuck, that's when you should go back and read the textbooks over your course notes. Okay, so the purpose of the assignments or quizzes is to make sure you learn the material. So you work on the assignments or quizzes and you will naturally learn the material. Okay, and it's only when you're really stuck on those that's when you should go back and sort of specifically read the textbook more, I guess. So I hope that's at least a somewhat reasonable answer. The answer is work on the problems you're given, and only when you're stuck, go back and read the book.
Okay, thank you very much. We have one more question, and we have Robert. To the audience, we have Robert for another 10 minutes. So feel free to ask your questions, and there is no question which is a small question. So feel free to send in your question.
Actually, there's one question in the chat about a sample lecture. So I don't. So here's what I can do. I don't have anything for Math 135. If you want, I'd be happy to give you a link to one of my videos I used for Math 138 this term. This was sort of the sort of thing I recorded. If you were sort of curious about this, I'd be happy to give you a link for this. Let me see if I can actually find this though. That might be challenging. One second.
Yeah, sure. That was a great question, everyone. You are going to get a sample lecture. So that is going to be helpful for you to prepare during your summers. And of course, that sets the expectation right for university. So
I mean, let me see if I can find this. I've got to,
yeah, sure, no problem. You can also send us later and we can send the link, Robert. So I mean, please look at it, but if it comes later to you, we are fine.
Okay, let me.
Yes, no problem. But yeah, if I could give an award to a question, I think that was the question that I would give an award to the best question asked in the session today. And of course, the Waterloo is competitive, so you can ask more questions like that.
Yeah, so I'm going to give a link to the chat. This is a link to a YouTube video. It's unlisted, meaning that you need the link to watch the video. You can't just find this by searching on YouTube. This, I have no idea what this is, just a random one I picked, but this was a video I made for my calculus course last term. So this was something there were no students in this Zoom call. It was just me recording this myself. So I'm just writing on a piece of paper. But that sort of, roughly speaking, sort of the material covered in one class. I don't even know what the material is, but anyway, you're welcome to take a look at that if you want. And that sort of about as much material as will be done in a typical class. It's probably only like 30 minutes long. And that's because I usually don't talk, like when I'm actually in class, I talk slower and there's questions, and that sort of brings it up to 50 minutes, which is how long a typical class is. But anyway, that's the best thing I can give you.
Yeah.
Hold on. I think I just sent it only to the people hosting. Hold on, I think I have to send it to everyone.
Yes.
Maybe you guys can see that. Maybe, I think before you couldn't see the first time I linked it. But anyway, that is sort of, this was something I recorded for people who couldn't come to class. Again, and this doesn't really give you an idea what a class is like, but maybe it's better than nothing. I'm not sure.
Okay, there was one small question that came up in between was, do students move in cohort ways? I mean, do the class, the students and the class size and everything remains the same from one year to the other and probably one class to the other, or they keep changing and they don't have a cohort, or they don't have the friends, I mean to say, in their group forever? I mean, how does that work in university setup?
Sure. I mean, this is sort of a jerk answer on my part, but in some sense, it's sort of, it's your job to sort of make an effort to stay in touch with people that you like. Okay, and this is something I learned as an adult too, and that sort of, if I want to be friends with someone, it's my job to put the time in. But that being said, so you're right, there are students with a different co-op sequence than you, but typically sort of, you do typically make close friendships with people who are in your sequence. Okay, but yeah, I mean, if you're entering here and you have a close friend who's in a different sequence, it's sort of, it's your job in some sense to sort of stay in touch with them in some sense. As far as the professors go, by the way, each term I get 5 students. Just last week I had a student drop by from 2 years ago to say hi and chat for a few minutes, and I love doing this sort of thing. I'm also way likelier to be willing to write a letter of reference for someone if they've dropped by over the years and said hello. But yeah, sort of, even with co-op sequences, you still drop by and say hello, or you do emails. But yeah, sort of, yeah, I guess I'm not really sure what else to say. I'm sorry.
Yeah.
Okay, 2 questions. Pavek, I'm not even going to let you talk here.
Yes.
So Abby said, how big is a usual class? And Pramit, I'm sorry, I'm probably saying that wrong, says, what is the average class size for first-year math courses? Okay, roughly speaking, I would expect it to be about 100 students for first-year calculus and algebra. So 135 and 137, you're probably in class of about 100 students. Maybe a bit smaller, maybe a bit bigger. For what it's worth, there will always be a decent amount of students who don't come to class because they're making bad decisions, and it will seem smaller than that for what it's worth. For what it's worth, when I end classes each term, if you are coming to class and if you at least sort of ask a question or answer a question once or twice, I know your name at the end of the term, I promise you. It will feel small enough where if you are active in class, I will know your name for what it's worth. But yeah, I would say about 100 students, but that's my rough guess.
Thank you. And everyone in the audience, we have just last 10 minutes. So I have a few questions on my board, but I will be, if you have any last questions, please drop in. There is one question that a student is asking is, what if a student doesn't score well? The question is about computer science, but even I feel for mathematics, that's a very relevant thing, that if they don't score well in a particular course, what it happens? I mean, do they have to repeat the course? What are the passing standards? And a few stuff, if you can just talk about, Robert.
Okay, so I should say I've never taught a CS course before. And I'm really just speaking about math here, but I assume it's similar for math and CS. So yeah, so in math, for example, so in first term, you take 135 and 137. And in order, so after, when you take 136 in your second term, and in order to be able to take 136, you need to get a 60 in math 135. Okay, now, if you do not score a 60 in math 135, we don't kick you out of the university. We don't send an angry letter to your parents, or make you walk through the streets and be egging you or anything like that. At that point, you can retake the course if you want. Okay, or you're allowed to sort of shift into a different program. But if you don't get the marks you need in first year, but you're able to try again. Okay, now one thing worth mentioning is, I mean, the university will charge you for that a second time because they're big jerks or whatever. Okay, that's out of my control. But yeah, yeah, if you don't get a 60 in a course you need to, you can take it again. Okay, and for what it's worth, this, I mean, hopefully this doesn't happen to you, but for what it's worth, there's way worse things in your like getting a 55 in one of these courses is really not the end of the world. And then there's way worse things that will happen to you in life than having to retake a course again, for what it's worth. But anyway, hopefully none of you get in that situation. Again, I can't exactly speak for CS, but I suspect it's similar. It's sort of, if you don't get the grade you need, you're allowed to try again. Yeah.
Perfect. Thank you so much. One question did come up to me sometime in between, that was like a direct message, is like, can you, a lot of these students will be selecting their majors at the end of the first year. Some would want to go into actuarial science, someone would go into data science, maybe pure mathematics. So how they should be choosing this and how competitive it is, if you can just reflect about it, that how do they choose their majors and how competitive it is?
Oh, I must confess, I didn't know you chose it first year. I thought it was like, this is how ignorant I am, that sort of, I love talking about math, but about how the actual university works, I'm sorry, I don't know that. So for what it's, okay, so first off, I'm pretty sure that if you end up choosing a major you don't like, you are able to switch. Okay, I'm pretty sure there are lots of ways to do this. As a rough answer to this, if you really like math 135, pure math or CNO might be one you want to look at. If you really liked calculus, then I would say you're more, I would steer you maybe more towards applied math or stats and actuarial sciences, but I don't know if that's a very good answer or not. But yeah, I mean, I didn't even realize they make you guys choose this in first year. I thought it was later than that. But
maybe at the end of the first year they have to decide, and then probably they take in the second year.
For what it's worth, I certainly don't think that decision you make at end of first year is permanent, and that you are allowed to change your mind, and it will not be a huge deal. Okay, because even in second year, regardless of what you're majoring in, most of you still take all the same courses, right? You're still going to take math 235, math 237, and whatever there's another course I forget the name for. So anyway, the short answer is I'm not totally sure, I guess, is my answer. I don't think I have a helpful answer for you. I'm sorry.
No problem. I mean, these are kids, they're asking and they have too many questions. So there is one more question that Prabha Sharan is asking, is about, can you take two majors? I mean, we are not talking about the feasibility standpoint of whether you can get it in a program office setup, but is it worth taking it? How challenging it could be to take two majors?
Yeah, you can take two majors, and you can take two majors in whatever you want in some sense, right? If you say I want to have a a double major in CS and combinatorics or CS and statistics, you can do that. It's probably a bit more challenging for sure, but you're able to take 2 majors in what interests you the most. Absolutely. I can't really, I'm not sure how much more work it is, but you're absolutely able to do it. And lots of students do it.
Great. So that's a cool motivation, everyone. There is one interesting question that came through chat is about, does their curriculum of grade 12, whether it is IB or Canadian curriculum, makes them more equipped for the mathematics in the university, or is it, I believe you're neutral, but if you have different...
My short answer is I think it is neutral. I don't think it's super important whether or not you took IB, and if anything, I think IB would be an advantage and not a disadvantage. Okay, that's my rough guess. Yeah, but it is certainly not a disadvantage.
Okay, and this is a final question that again came to me, and then we will wrap up the session. Is like, are the required books available online, or they have to purchase, or?
Yeah. Sure. Yeah. I saw that and I forgot I was going to mention it, but it disappeared from the chat. Okay. Yeah. So, yes. So for example, in 135 and 137, there's a textbook that we make at Waterloo, and we give you the PDF for free. Okay. Now, one thing worth saying is that I don't think you can find it online if you just Google it. I mean, I think you have to be registered in the course, but that being said, if anyone here wants to email me and ask for the course notes, hang on. I just put my email in the chat. If you send me an email and saying, I'd like to see the course notes for the first year courses, I will send them to you. Okay, and that's, you don't have to buy the book, but when you buy the book, it's just a copy of those printed on paper, and then they charge, I don't know, $20 for them or something. So if you send me an email, I will happily send you the course notes for 135 and 137, provided I can find them, but I'm pretty sure I can. So yes, we provide you the course notes online as a PDF, and you don't even have to buy a paper copy if you don't want.
Great. I think we are at the end of the session, and we have exhausted all the questions. And Robert, thank you very much. You took a lot of time.
My voice is starting to go a bit.
Yeah, exactly. You need a cup of coffee and maybe a little bit of water. But yes, thank you very much for everyone who came here today. And thank you very much, Robert. It was a pleasure, like every year, to have you and talk to our students. We have one more session. Those who have been asking CS questions, there is a different session for the CS group, and that is going to be there on Tuesday morning by one of the professors at CS, who's Jeff Avery. So you can direct all the CS questions there, and we will be happy to see you. Thank you so much, Robert. I think we are done, and this is the end of the session. So we will wrap it up. Thank you very much, everyone. Have a good weekend.
Yeah, I hope you at least heard something a little bit useful, and have a good weekend, everyone. All the best.
Thank you, and hopefully we see you in Waterloo.